Right, so this is an eddy covariance system. It's used for making field scale measurements of carbon sequestration. So what we have here are two fields, one that's been grazed, it's been grazed for the last couple of weeks, and one that is about to be newly grazed. Okay, so you can see the differences between the two different systems. We have the eddy covariance system in between it, so when the wind direction is coming from over there, and we're measuring over that field, and when the wind direction is coming from this direction, we're measuring over this field. In order to measure the fluxes, what we're essentially measuring is we're measuring the amount of respiration going out of the system and the amount of photosynthesis coming into the system. And for that, we're measuring the turbulent flux of eddies in the atmosphere. So eddies are like circular motions of air, and what we can do is measure the vertical wind speed of that air, the CO2 concentration of that air, and as the concentration changes over time, we can measure a flux because we have velocity, we have concentration, and we have a time component, so we can measure a flux. In order to do that, we need two pieces of equipment. A 3D sonic anemometer, which is the piece of equipment with the teeth in it there, and that's measuring wind speed in all three dimensions, and then an infrared gas analyzer to measure CO2 concentration, and that's the piece of equipment with what looks like a ball at the top. It's an open path gas analyzer, so it sends a beam of infrared light from the bottom up to the top receiver and measures the CO2 concentration in between. Now note how they're arranged. You can see that they're quite closely aligned to each other, so they can measure vertical wind speed and CO2 concentration within the same eddy. But we set the infrared gas analyzer back from the anemometer, so we're not disturbing, or we're disturbing the wind speed as little as possible. Okay, also note the height of the instrument. It's set at about 2.5 to 3 meters above the canopy, and that's so that we get small eddies. We get a good contribution of small eddies and larger eddies at the same time. Also note that there's ancillary measurements being made. In order to correct the flux, we need to know the air temperature and also the relative humidity. This is a relative humidity sensor with aspiration shield on it, measures air temperature as well. All the data is sent down into a data logger here. So the data logger is in here, and it records all the data to it. Other ancillary measurements we need to measure is we need to know the energy balance of the system, so the energy coming into the system and energy going out of the system. So we have this piece of equipment, a net radiometer here, and then in the background that black sensor there is a PAR sensor, and that measures the amount of photosynthetically active radiation, i.e. radiation that's taken up by the plant. And then we can do light response curves, so we can graph light level against the amount of photosynthesis and work out the light use efficiency of the canopy. We also have webcams here, and the webcams are to create vegetation indices. So to get a correlation between the vegetation indice and the amount of biomass, and we need a grayscale and then calibration sensor in order to calibrate that greenness index relative to the light level that's occurring at the time. This is a very low power piece of equipment, so it can be run in the field off batteries and solar power, so it's ideal for use in more remote locations.